If you walk through a medieval harbour, a ruined monastery, or the frame of a centuries-old barn, you will notice something unsettling. The wood is still there. Not preserved behind glass, not sealed with modern polymers, but exposed to rain, fog, soil moisture and salt air for hundreds of years. These builders did not have pressure-treated lumber, synthetic sealants or laboratory coatings. What they had was a deep, practical understanding of moisture, wood fibre and decay. Today, wood rot remains one of the most expensive and persistent problems in construction, homesteading and outdoor survival structures. Decks fail, fence posts crumble, boats soften from the inside out. Medieval builders faced the same enemy and solved it with a moisture barrier so simple and effective that most modern builders ignore it entirely. In this guide, we are going straight into the method, the materials and the logic behind it, so you can understand exactly why it worked then and how it still works now. So, medieval craftsmen understood a lot about wood and water. They realized that rot doesn't actually start because of age. Instead, it's all about trapped moisture. Wood, interestingly enough, can survive wet conditions for ages if it's allowed to dry out again. But, it fails rather quickly when water gets sealed inside the grain. Their approach wasn't really about making wood completely waterproof, but more about managing how moisture moved through it. They paid close attention to things like grain orientation, the difference between sapwood and heartwood, and how water travelled along the fibres. The key insight, really, was that rot fungi need three things: moisture, oxygen, and digestible cellulose. If you remove any one of those, decay slows right down to a crawl. So medieval moisture barriers were designed to interrupt this triangle rather than, fighting nature outright. Now, this is where the oldest moisture barrier enters the story. The most widespread medieval wood preservation method was the use of pine tar, often combined with animal fat beeswax or resin, to create a breathable but water-shedding barrier. Pine tar was not paint. It did not sit on the surface as a brittle shell. Instead, it soaked into the wood-filling capillaries while remaining flexible. Viking ships, medieval bridges, roof shingles, barrels and ground contact posts all relied on this treatment. Archaeological timbers pulled from Scandinavian harbours still carry traces of tar after nearly 1,000 years. The barrier worked because it repelled liquid water while allowing slow vapour movement, preventing internal condensation. This section breaks down how pine tar actually prevents rot. Pine tar is produced by slowly heating pine roots and resin-rich wood in low oxygen. The result is a viscous, acidic substance loaded with phenols and resins. These compounds are, naturally antifungal and antibacterial. When brushed or heated into wood, pine tar migrates deep into end grain, which is, where most rot begins. It displaces water, coats cell walls, and leaves behind a rather hostile environment for decay organisms. Unlike modern sealants, it does not crack under temperature changes or ultraviolet exposure. Medieval builders reapplied it periodically, understanding maintenance as part of longevity, rather than, a failure of design. Here is how medieval craftsmen prepared and applied the barrier in practice. Before application, wood was seasoned but not kiln-dried. Slight residual moisture helped draw tar inward as it cooled. The tar was warmed, sometimes thinned with linseed oil or animal fat, and brushed generously onto the wood, especially end grain, joints and contact points. In shipyards, planks were heated in the sun or over low fires to encourage absorption. For posts set into the ground, only the lower section was treated, often with repeated coats over several days. The treated area darkened, became water-shedding, and emitted a resinous scent that insects avoided. This was not cosmetic. It was functional chemistry. So, in this part, we're going to talk about how you can, actually use these same principles today. It's not just old history. These methods still have a place in the modern world. If you're building a fence, a shed, a raised bed, or even a small boat, you know the medieval method is still a really viable option. First, try to select wood with intact heartwood whenever you can. Then, gently warm your pine tar until it flows easily. Don't rush it. Now, you want to apply it heavily to all the end grain and any surface that'll face soil, standing water, or, repeated wetting. Let it soak in, then reapply until the wood just stops absorbing. For above-ground structures, thinning the tar with a bit of raw linseed oil helps it penetrate better and, reduces that sticky surface feel. The result might not look modern, but honestly, it'll function exceptionally well. So, in this section, we're going to compare medieval barriers to, modern failures. It's quite revealing, honestly. Modern pressure-treated lumber, you see, does resist insects, but it often traps moisture beneath those surface coatings. And, acrylic sealers might look clever, but they form films that crack invisibly, letting water in but not out. It's a bit of a problem, really. Now, medieval tar barriers, they cleverly avoided all this by remaining semi-permeable. They aged slowly, darkened gracefully, and could be refreshed without any need for stripping. The philosophy back then was all about long-term stewardship, not just disposable construction. And, this mindset really explains why so many medieval wooden structures still stand today, outlasting their modern counterparts, even though the tools they had were, far less advanced. This is why this knowledge matters beyond history. For survivalists, off-grid builders, and serious historians, medieval moisture barriers offer reliability without dependence on industrial supply chains. Pine tar can be produced locally, stored indefinitely, and applied with minimal tools. In wet climates, this method can mean the difference between a structure lasting 5 years or 50. Understanding it connects you directly to the practical intelligence of past societies that built for generations, not inspection cycles. This closing section brings it all together. Medieval builders did not defeat wood rot by sealing wood away from the world. They worked with moisture, fungi, and time itself. Pine tar and natural resin barriers represent one of the oldest, most proven moisture control systems ever used. It is not forgotten because it failed. It is forgotten because modern building forgot how to think in centuries. If this guide added real value to your understanding of historical technology and practical survival knowledge, subscribe to the channel, share this video with fellow history enthusiasts, and help keep these methods alive for the next generation.